Hi, I'm Brian Boam, CEO of Network Consulting Services Incorporated.
And hi, I'm Bryan Hadzik, CTO of NCSI.
In our continuing video series on effective web security that starts outside the perimeter, today we're going to discuss advanced bot protection.
Yeah, this is a really interesting one. Bots are an incredibly complex thing. They seem like they're relatively simple when you start with it, but as you peel back the layers of the onion, you see there's really a lot going on there. We've got good bots, we've got bad bots. We can't just block all of them or we're going to drop off a Google search. And as we kind of dig into it, we see that it's ever changing, kind of evolves very rapidly. And it's difficult to keep up on all the new changes that are happening inside of bot technology. Anything that is this kind of complex, we want to make sure is as far away from our network as possible. So again, farther upstream where we're protecting ourselves long before it gets to our web servers.
Yes, and in the previous videos that we've done, we've talked very specifically about the cloud infrastructure that we've used from Imperva to handle the WAF and other technologies that we want to keep outside the network. We're going to now look how to use that same cloud technology in the advanced bot protection.
Should we take a look?
Let's do it. All right, let's talk about bot protection. So what's the problem? There's good bots and there's bad bots. We have to be able to distinguish the difference, and we don't want to do it once it hits our website. We want to be able to do it far away. So let's look at one of the very first problems that we have to deal with. It's called credential stuffing. This is extremely common. It is very easy to go out to the dark web right now and buy tens of thousands or millions of usernames and passwords that have been hacked or exfiltrated from other databases around the internet, and buy them and use bots to do the heavy lifting to go out and simply pound websites, pound Netflix, pound Amazon, pound any of these websites out there that we can use to try to see if this username and password has been reused on these websites. Maybe it's been reused on your website and you don't know that. So we have to be able to protect our users by looking at those bots that are trying to do credential stuffing. Next thing is look at the retail offerings that are out there. Maybe it's a gift card, maybe it's just simply a way to purchase off your shopping cart. We have to protect our users and protect ourselves against bots that are out there simply trying to autofill out forms. Maybe taking advantage of a legitimate offer that we're using to try to garner more clients, but using it against us with a bot that's simply out there trying to sign up for a new offer over and over again and try to steal information from us one way or another. We don't want that either. Now think about scraping. Now this could be a good thing as well. You have information on your website that could be indexed through a search engine to help customers find you easy. That's awesome. We want to avoid the fact that there is also scraping out there that goes on that takes that information and gets it to our competitors or uses it against us somehow or another to match our best sales price or match our best quantity loads that we can sell. So we want to be careful on this and make sure that those bots that are scraping us to steal information are distinguished from the ones that are actually indexing our website for a good purpose. Now here's the last one. This is pretty interesting. You probably heard a lot about IP reputation. Well, IP reputation is not necessarily good enough. It's not necessarily a one-to-one scenario. Keep in mind that if you wanted to block a bad IP address right now, you could actually be blocking tens of thousands of IP addresses because they're natted behind a firewall. So we have to be able to know the difference between how to protect a single IP address's reputation against blocking all of the valid customers that we want to be able to do this. So let's take that information and make sure all of that happens outside our network so that by the time that traffic reaches our web server, we can already trust it. So let's turn it over to Brian, see how he can handle that for us.
All right, so we've talked about the theory behind the bots. Let's dive into some of the more technical details on what these good bots and bad bots would potentially look like. So first of all, in our example here where we've talked about when the device is going to communicate up to our website, if it is a bot, if it's something like Google and it's indexing our website, that's a good thing. We want to go ahead and allow that. Well, how do we help identify what are good bots and what are bad bots? Well, there's something called the user agent. The user agent is how the device actually identifies itself. So when you have something legitimate like the Google indexer out crawling the web, it identifies itself as such. And so it's very easy. Okay, that is a good bot. So identifying good bots is actually pretty easy for us. The hard part is that this user agent that's just supplied by the web browser. Web browser just comes in and says, hey, I'm Chrome, I'm running on Windows, here's the information about me. It's completely provided by the end device. Go Google looking for like a Chrome user agent switcher. You can make it look like you're running on a toaster and you're running Netscape Navigator, since all that information is just supplied by the end device. So we can't really rely on that alone. So if you have bot protection today or you've heard about it, it's probably just simple user agent based. We have a lot bigger problems. The really bad bots, they're not going to tell us that they're malicious. They're going to, attempt to appear like they're legitimate. So we need to do more than just that. And then we have things like, NAT. Probably this device doesn't directly connect to it. It's probably something like this, where we actually have a natting device. So this is a firewall or something like that. And then potentially behind it, we might have, thousands of devices that are sharing that. So knowing the IP address and understanding its reputation or what it's doing isn't the only piece of information. The bottom line is we have to have a multifaceted approach. It can't be just a single piece of information that we're going to base it on. That's where we come in and we talk about our high-def networking, our high-def fingerprinting. The concept behind this is I want to be able to have a lot of information about that. We have something like 200 attributes that we're going to gather. We're going to understand the user agent, the IP address. On the back end here, we're going to interrogate that browser. This is the Chrome browser that the user or potential bot is looking for. We're going to identify that. We're going to try and understand if it's an automated browser or using some kind of emulation to show that it's a different kind of browser. So we're going to interrogate that, store those 200 attributes, and then we can do something with it. We can choose whether we want to allow it or not. Maybe we don't want to flat out block it. We want to, slow it down, do a rate limit that says, hey, you can still use our website, but we're going to limit the number of requests that you have. Or maybe we want to go and do something like a CAPTCHA, where we are going to force the user to prove that they're actually a human and not a bot. Now, the beauty of it is we don't have to do it across all of the different devices back there because we're not doing it just solely based on the IP address here. So you can have multiple sessions going through this device and we can individually interrogate and fingerprint those sessions and not necessarily just entire subnets out there. So this is how our advanced bot protection works. That's kind of the theory behind it. Let's go jump into the console and see it in action. All right, the kind of attack that we're going to do from a bot perspective today is something called account takeover. We have a website. We're going to take a list of usernames and passwords that we found at a compromised website, and we're going to try and attack this. Password saving or password sharing is a big problem that we have. You use the same kind of password on multiple different sites. So just because you use the same password on website A and it got compromised, we can go to a non-compromised site and still use that account details. So this is the website that we're going to attack. Here's the actual login page that I have an account on. Here on an attacker machine, you can see we have a list of user credentials that we have purchased off the dark web or something like that, and we're going to use this in an automated attack against that website to see which ones are legitimate. Let's see how we can configure our protection first. So here in the Imperfect Cloud WAF, you can see under the account takeover section, I can create a customized policy where, if there's a high attack probability, should we block it? Should we turn on a CAPTCHA? Should we do something like that? This gives us the ability to control exactly how this kicks in and how the protection works. We can even simulate it and try and predict what the future would look like based on the previous results. So let's go ahead and apply that to our website from a protection perspective, and let's go kick this off. So this is an automated attack. What's going to happen is it's going to open up a Chrome browser and then simulate logging into this website repeatedly over and over again with various usernames and passwords until we potentially have a hit. So this is a kind of a spraying attack where we're going to go over and over and over. And if you look really close, one of those actually succeed. If we look at the log here, it's going to come back and say, hey, this particular account was actually a success. That user was able to get past it. Now, at this point, you can see we've actually understood that this is an attack, and we've kicked in our blocking mechanism and said, we are not going to allow you to get to this website, or we could have turned on that CAPTCHA to provide a secondary check to see if it really is a a human there doing it, but we've recognized that this is a bad actor attempting to hit our website. If we go over to the console here, we can kind of see a history of what's been going on. We can see, the total number of login attempts, how many account takeover attempts, and then actually individual compromised users. So if we click on the details there, we can go in and see users that have actually been compromised. Maybe I need to go and reset their accounts, or I need to be able to tell them that there's a problem with their account and lock things out. So that's our account takeover protection.
Thank you for taking time to watch NCSI's video series on effective web security that starts outside the perimeter of your network. This is a 3-part series highlighting Web Application Firewall, Distributed Denial of Service or DDoS, and bot protection. If you have additional questions, please reach out to an NCSI representative at sales@ncsi.us or call 801-295-7555. Have a great day.